Chernobyl. The name alone evokes the worst nuclear disaster in history, a catastrophe that still casts a long shadow over nuclear power. Yet, for decades, an extraordinary international effort had not only contained its immediate dangers, but had begun to heal Ukraine's terrible wound. Thanks to unprecedented global collaboration, the site was, in a way, fine. The open wound had been bandaged, the immediate risks mitigated. But then, earlier this year, the unthinkable happened. A drone attack tore a hole in the multi-billion-euro shelter designed to keep the infamous Reactor 4 and us safe. So, is Chernobyl truly okay? And what happens now? This monumental structure is the new Safe Confinement, or NSC. It's a vast feat of engineering, entombed around the infamous Chernobyl Reactor 4, the culmination of a monumental €2 billion international collaboration. Designed to stand for 100 years, it was built to withstand the worst Mother Nature could muster: earthquakes, lightning strikes, and tornadoes. But no one ever imagined it would have to survive times this. Just after 2 a.m. on the 14th of February 2025, a Russian Dranto drone struck the northwest corner of the NSC. A horror, to be honest, recalls Simon Evans, head of the International Chernobyl Cooperation Account at the European Bank for Reconstruction and Development. He adds, "I was gobsmacked. Evans has dedicated the past few decades to safeguarding Chernobyl's future and coordinating the funding for the NSC's construction. The strike caused a hole of approximately 15 square meters, penetrating both the external and internal cladding on the northern side of the new Safe Confinement. As fire crews raced to douse the flames, it quickly became clear that the damage extended far beyond the impact site. Thermal imaging footage revealed the fire had begun to spread inside the roof's cladding. Firefighters drilled holes above the smoldering material in an attempt to extinguish the blaze, but their efforts were severely hampered by the bitter Ukrainian winter. With air temperatures plummeting to -16 degrees Celsius, the water froze before it could trickle down and quench the flames. One firefighter narrowly escaped death when his rope was severed by a shard of twisted metal. It took 7 fire hoses, spraying water non-stop for 17 days, to finally bring the inferno under control. On March 7, the fire was declared over. In addition to the enormous blast hole in the roof, approximately 200 square meters of cladding, covering most of the northern side of the arch, had been destroyed. For Chernobyl, the new Safe Confinement represented the pinnacle of remediation efforts. As impressive as its physical structure was, it embodied far more than just steel and concrete. It was a brilliant solution to an impossibly complex problem, finally allowing workers to begin the arduous task of demolishing and clearing the crippled reactor site. Yet, in the early hours of that fateful February morning, that meticulously crafted plan, and the profound hope it carried, was being reduced to ash. To truly grasp the catastrophic nature of this attack, one must first understand the inherent dangers of Reactor 4. The explosion at Chernobyl was not a nuclear detonation in the sense of an atomic bomb. Rather, it was a runaway nuclear reaction. My name is Jim Smith, introduces Professor of Environmental Science at Portsmouth University. I've been studying the Chernobyl accident since 1990. In the early hours of the 26th of April, 1986, a routine safety test in Reactor 4 triggered a runaway chain reaction. The intense heat generated led to a buildup of hydrogen gas, culminating in a massive explosion that exposed the reactor core. It's crucial to remember that this accident emitted vast quantities of radioactive elements, specifically fission products. Professor Smith explains, "We're not primarily worried about the uranium that formed the reactor and its fuel. Our concern lies with the substances uranium splits into during radioactive fission within a nuclear reactor. These deadly fission products were violently expelled from the reactor core's safety into the surrounding structure and then propelled into the atmosphere as a lethal cloud of dust and gas. Over the subsequent 10 days, that radioactive cloud drifted across the surrounding region, its deadly particles gradually settling to Earth. Professor Smith describes the aftermath. There's a hot spot close to the plant, particularly what we call the Red Forest. The Chernobyl accident occurred in spring, and this area earned its name because trees died across approximately 10 square kilometers of forest due to the intense radiation. He adds, "It could be hundreds of years before it's completely safe." But here's the chilling truth. The cloud that wreaked such havoc carried only 5% of the nuclear waste from Reactor 4. In other words, a staggering 95% remains trapped inside, still waiting for a chance to escape. Back in 1986, once the fires from the explosion were extinguished, immediate attention shifted to containing the remainder of Reactor 4's deadly inventory. To achieve this, they constructed what became known as the shelter object, or the sarcophagus. Construction began in June 1986, just 2 months after the disaster. The northern side of the reactor was buried under wreckage. Instead of attempting to clear it, work began on encasing it within a colossal stepped wall. Steel slabs formed a mold, and contaminated vehicles and crane sections were used as infill before vast quantities of concrete were poured. 3 tiers were constructed to encase this side of the reactor. On the south side, an enormous steel support, dubbed the Mammoth Beam, was laid. L-shaped steel slabs, known as hockey sticks, were then positioned atop this beam to enclose the structure. The roof was formed by installing a raft of steel pipes over hastily erected supports. In November 1986, after an intense 206 days of frantic construction, the sarcophagus was complete. It was a truly heroic structure, built under immense pressure, yet its hurried construction inevitably led to significant compromises, making it far from ideal. By 1996, a mere decade after its completion, serious warnings about the sarcophagus's structural stability began to emerge. Without reinforcement, experts feared it could collapse within years, unleashing another, even larger, plume of radioactive dust into the atmosphere. For the Chernobyl nuclear power plant, authorities tasked with decommissioning the site, this scenario would have transformed a bad dream into an absolute nightmare. Not only would they face the challenge of safely demolishing the reactor's mangled wreck, but they would first need to figure out how to remove thousands of tons of highly radioactive, splintered steel and concrete. A new, permanent solution was desperately needed. Consequently, in 2001, following years of fundraising from agencies across the globe, design work for the new Safe Confinement commenced. The new Safe Confinement was thus designed with 2 critical objectives. Firstly, it aimed to prevent the release of radioactive dust into the environment should the sarcophagus collapse. Secondly, it was to provide a secure structure internally equipped with cranes, enabling the dismantling of the sarcophagus and the safe removal of nuclear fuel from the site. The plan envisioned a colossal hangar that would hermetically seal Reactor 4 and its sarcophagus. Measuring 160 meters long, 260 meters wide, and 108 meters high, this enormous structure could have easily encompassed the Roman Colosseum. The NSC's immense size wasn't just to cover Reactor 4. Crucially, it also provided the necessary space to survey and deconstruct this incredibly complex wreck. However, its sheer scale presented unique challenges. Due to the severe radiation risk, constructing the NSC directly over the reactor was strictly impossible. Instead, it had to be built on tracks 150 meters away and then slid into position. Even with a vast, specially constructed work area, there wasn't enough room to build the arch in a single piece. Engineers devised an ingenious solution. Construct the structure in two halves. Once the first half was completed, it would be slid to one side to create space for the second. The first section would then be slid back, and the two halves welded together. Construction commenced in 2010. Again, due to the structure's enormity, a traditional ground-up build was unfeasible. Instead, it was assembled from the top down. The arch's center section was constructed first, near ground level, before being hoisted upwards by powerful strand jacks. These jacks operate by feeding a bundle of steel wires through two clamps. The top clamp grips the cables and lifts them, while the bottom clamp secures the bundle, allowing the top clamp to descend and repeat the process. As the center was progressively raised, the two side segments were pulled into place. Examining the internal structure of the roof reveals a series of 1-meter wide steel pipes running horizontally across the entire span. These are secured by a lattice of steel beams fastened with pretension bolts, creating a 10-meter wide void between the upper and lower sections of the roof, known as the annular space. This annular space housed critical systems that, once operational, regulated humidity and maintained a band of high-pressure air. The absence of moisture preserved the steelwork, while the pressurized atmosphere ensured that any small punctures in the ceiling would cause air to flow times from times the roof times into times the space below, effectively preventing outward leaks. However, when the drone strike hit, it blew a hole through both the upper and lower parts of the roof, resulting in a total loss of this crucial air pressure. Now, should any dust be generated by a collapse, there is nothing to prevent its escape through this breach. The roof itself comprises a sophisticated layering of materials. The inner roof is lined with beveled stainless steel panels, specifically designed to reflect gamma rays back towards the reactor. The outer roof, conversely, is engineered to be as smooth as possible, facilitating the shedding of rain and snow. Beneath this outer surface lies a combination of various insulation types and a synthetic rubber membrane. These layers were intended to protect the NSC from precipitation and extreme weather. Tests demonstrated that a lightning strike would only damage a few millimeters of thermal insulation without igniting the membrane beneath. Yet, while these layers were perfectly designed for natural elements, they inadvertently contributed to extensive damage following the drone attack. As the explosion breached the roof, the cladding was exposed to fire, igniting the internal membrane. This then began to smolder, causing the most widespread damage. The thermal insulation further hampered firefighters' efforts by concealing the full extent of the smoldering from thermal imaging cameras. By April 2016, construction of the NSC was complete, with only the final, monumental task of sliding it into place remaining. The entire 36,000-ton structure rested on a series of skid shoes, individual jacks, that propelled the arch along Teflon rails. This was, at the time, the largest moving land-based object ever built. Traveling at a deliberate pace of 10 meters per hour, it took a painstaking 15 days for the structure to reach its final position. To be honest, I felt a little bit emotional at the time, Simon Evans admits. I was a bit surprised at myself, because it's just a big lump of steel, and we'd been dealing with it for many, many years. He continues, describing the site. To my left, you can see the new Safe Confinement, which encloses the destroyed Reactor Unit 4. We are at the point where the confinement interacts with the old facilities, and we obviously have to ensure there's a hermetic seal between the two. This ongoing work involves a continuous membrane, an example of which you see here, that extends all around the entire circumference of the new safe confinement, sealing it with a destroyed sarcophagus. Overall, we have about 2 kilometers of this membrane. Although the physical move was completed in November 2016, construction and rigorous testing continued for another 3 years. Its final completion marked a moment of profound celebration, a sense of truly healing, a scar that had blighted the region for decades. Finally, in July 2019, a ceremony officially handed over the facility to the Ukrainian authorities. The new safe confinement then began its century-long vigil over the destroyed reactor. However, that crucial watch would last barely 6 years before coming to a devastating end. Yet, as dramatic as the drone attack was, it is far from the only threat that has cast doubt upon Chernobyl's future. The power plant was captured by Russian troops on the very first day of the full-scale invasion of Ukraine in February 2022. News reports confirmed. This morning, the Chernobyl nuclear site in Ukraine is now under the control of Russian troops. As military vehicles drove off-road through the exclusion zone, clouds of radioactive dust were stirred into the atmosphere. Shockingly, soldiers even dug trenches while taking up defensive positions directly in the highly contaminated red forest. According to Ukrainian authorities, several soldiers were later treated at a specialist radiation hospital in Belarus, with one reportedly succumbing to acute radiation sickness. Russian forces withdrew a month later, but their presence and the profound effects of the invasion have left an indelible mark. The war has not only ravaged the physical infrastructure of the site, but also decimated the crucial network of expertise required to decommission such a vastly complicated nuclear facility. Simon Evans elaborates. There's also a human capital issue, which I think is one of the real understated problems. Many of the experts and people we work very closely with are simply no longer there anymore. It requires expertise, it requires individuals, and rebuilding that knowledge base is going to take a huge amount of time as well. Life has become even more arduous for those still working at the plant. Following the evacuation of Pripyat, workers were housed in a newly built city 50 kilometers to the east. But since the invasion began, that distance suddenly feels far greater. Simon Evans explains the logistical nightmare. They used to be able to get to the site within about an hour on a dedicated train line that went through Belarus. That train line is no longer operational. Workers now face a 5.5 to 6 hour transfer to the site. As if that weren't challenging enough, an alternative bridge nearby was also destroyed, sabotaging shorter routes to the plant. Evans emphasizes, tremendously difficult things have occurred that perhaps we don't often consider because they aren't quite as sexy as the complex nuclear engineering challenges we face. However, they are absolutely essential for stable site operations, and those conditions are simply not present at the moment. We spoke to several individuals at the CHNPP for this video, and they all highlighted funding as their biggest challenge. After the NSC's completion, Ukraine had committed to funding the entire site's decommissioning. But now, with a war to finance, the available funds have plummeted dramatically. So, what is the fate of the new safe confinement? It's crucial to acknowledge that in its current state, there is no immediate danger. However, that situation could rapidly change if the sarcophagus, now in a highly precarious position, were to collapse. In the short term, authorities aim to patch the hole created by the drone and the 300 other holes drilled by fire crews. Yet, this is merely a temporary fix, not a permanent solution. For the long term, no one truly knows what to do. Simon Evans states, how you start to repair the longer-term functionality of the arches is still not yet known, but we do have some work underway to come up with engineering solutions. I think it's unlikely that we will be able to simply replicate the original design and repair it. We're going to have to look at other alternative options, which might include a reduction in the lifetime of the arch, which was previously 100 years. One initial suggestion involved detaching the affected half of the shelter and sliding it back to the construction area for repairs. However, after thorough investigation, the consortium that built the NSC deemed this impossible. If any positive emerges from this grim situation, it is the undeniable truth that, despite the profound tragedies at the Chernobyl site, immense progress has been achieved through international collaboration. Even as circumstances appear bleak, that spirit of cooperation remains undimmed. The European Bank for Reconstruction and Development, EBRD, so instrumental in funding the NSC's original construction, is already working diligently to secure funds for its repairs. And in the face of indescribable hardship, the dedicated team at the Chernobyl nuclear power plant has lost none of their determination to rectify this critical situation. Simon Evans concludes with a note of hope. I think we have causes for hope. If you look at the circumstances Ukraine is facing and the work they have already managed to put in to keep Chernobyl safe and secure under unbelievably difficult circumstances, that's tremendously inspirational. But I also think that the international community has stood up and recognized that this is not something they are prepared to leave Ukraine to suffer and deal with by themselves.